Hi everyone, welcome back. We're going to do some work with writing exponential functions, and we're going to talk about growth functions and decay functions. So this is for IM1. We will see this in IM3 as well, but this is definitely at an IM1 level, and we'll talk about what that means for the problems we're going to do. Okay, so the first thing we want to do is write our formulas that we're going to use in order to calculate the growth or decay of these situations. The first one we have is our growth formula. We'll write these out and then we'll talk about what each piece means. So for this one, we're going to say y equals a times, and then we're going to have 1 plus r raised to the t power, the power of t. This is a lot like a basic exponential function, a times b to the x, but this time we've got some added variables here. Our decay function is almost the same, but of course this is representing something getting smaller. So we've got a times 1 plus, and I actually want to write a negative there. So I'm going to use my handy dandy whiteout. And this is going to be minus r to represent decay or getting smaller. Okay, so the 3 variables that we want to define first is a. This is going to represent whatever amount we start with. So we're going to be talking about population, values of cars and things. So the first thing we have is a. This is the initial amount. So you'll see that in both formulas right here. The second thing we have is our r value. This is the rate of change, so the rate of growth or decay. So we'll say rate of the growth or decay, just depending on the problem. And for these, we are going to be given percents, but we're going to write them as decimals. So the problems are going to have percents, but when we plug in our or substitute our r value in, it needs to be a decimal. So I'm going to remind myself that I'm going to go from percent to a decimal, and we'll do some practice in a moment on that. The last thing is t, and you may recognize this from other formulas. This is going to represent time. For most of the problems on this worksheet, this is always going to be years for this worksheet. It can be in other increments of time, but years is the most common. All right, let's get started. So I've got a problem here about a painting, and it is sold for $1,800. So that's our initial amount. Its value is going to increase by 11% each year, so it's getting more and more valuable. And we want to find the value in 30 years. Okay, so let's take a look at the formula that we're going to use. This is increasing, so this is a growth. So I'm going to rewrite that formula right here. Y equals a times 1 plus r to the t. And then what we'll do here is substitute all our values in that we know. So y equals my initial amount. That's going to be my $1,800. That's what it starts with. That's how much it is at the beginning. And then we've got 1 plus. Now careful here, we don't want to write 11. We want to write 11% as a decimal. So let's do that real quick off to the side. We want to write this as a decimal. So 11%. We want to take the decimal that's in this imaginary number right here. It's not written, but we know it's here. And we want to move it to the left 1, 2 times. So as a decimal, this is going to be 0.11. Okay, now we're ready to substitute our r value in. So where r is, we want to write 0.11. And then the last thing we have is t, and it's in time. It's 30 years. We want to know how much this painting is worth in 30 years. So let's put a 30 there as our exponent. All right. So when we do our calculation here, I'm going to rewrite this one more time. I'm going to add these two numbers together since they're in the parentheses. So I've got 1.11 to the 30th power. So in your calculator, you're going to do 1.11 raised to the 30th power, and then times by 1,800. So we get that y is about, I'm going to round this number, 41,206.13. And we're talking about money. So I'm going to put my $sign there. Okay, let's try another one. This one is also a growth situation. We've got a bank account or a savings account, and it's opened with $350. So maybe you open it up and you only have $350, so that's what you put in. And it's going to gain 2.7% yearly for 5 years. So again, I'm going to write my formula, and then we are going to substitute our values that we know into the formula. So it's growth. I want to have a plus R. And then underneath, y equals, so our initial amount, our A, is 350. I've got 1 plus, once again, careful here, I want to write 2.7% as a decimal. So if I move this decimal over to the left, 1, 2, that's going to be 0.027. That's 2.7% as a decimal. And then raised to the 5th power because it's after 5 years. So again, I'm going to rewrite this one more time so we can easily plug this into our calculator. I just added these two numbers together in the parentheses. So 1.027 raised to the 5th power, and then times 350. I'll do that for you guys on here just so you can see. So 1.027 raised to the 5th power, and then times 350. So I get this amount right here. I'm going to write that so that it looks like money. So we've got $399.87. So after 5 years, if you put $350 into this savings account, you will now have $399.87. Okay, last one. Let's do one more type. This says the value of a car is depreciating, so it's decreasing, going down, at a rate of 5% per year. In 2021, the car was worth $32,000. Find the value in 2024. So I need to do a little bit of detective work here because I'm not given the amount of years. I am given the start and end year though. So from 2021 to 2024, I need to find out how many years that is. So I'm going to do 2024, and that's going to give me 3 years. So I know which value I'm putting in for t. Okay, let's get started. This time I'm going to be using my exponential decay function. So I'm going to use y equals a times 1 minus r. Okay. Y equals, my initial amount is 32,000. That's what value the car had at the beginning or in 2021. We're going to do 1 minus 5% as a decimal, and then raised to the 3rd power since we're talking about after 3 years. Okay, so this is 32,000 times, and then this is going to be 0.95. I just did this subtraction, raised to the 3rd power. Once again, we're going to take this number, raise it to the 3rd power, and then multiply by the initial amount. So you should get, our final answer is 27,000. And we have 436. Okay, this again was about dollars, so I'm going to put that in my answer. Just a reminder, guys, sometimes these problems are going to be about population, things, money, so we won't always put a $sign as our answer, just depending on if that's what we're asked for. Thanks so much for watching, guys. If you have visited my website, this set of notes has a bunch more problems on the back, so take a look on my website or Google Classroom for those solutions. Thanks so much for watching, guys. Have a great day.